evening, ladies and gentlemen. I would like to take this opportunity to welcome you all to this webinar on empowering model-based enterprise with digital product information. My name is Surendran. I'm an application engineer at Conceptia Software Technologies Private Limited, Bangalore. So today's webinar will be an essential learning to understand the insights of model-based enterprise, and also let's see how digital product information can help organizations to establish the concept of model-based enterprise to make the process more effective from design to manufacturing. So in turn, they can reduce the time to market and stay ahead of the competition. So this is the agenda for the next 45 minutes. So first, let us see what is model-based enterprise, and followed by which what is the importance of digital product manufacturing information or the digital product information in the model-based enterprise again. So even before we make a transformation to any of these new technologies, it is very much important that we need to be at the basics and understand the fundamentals before the transformation. So here let us see what are the fundamentals that are required even before we make a transformation to the model-based enterprise. So beyond all these things, the most important thing that we are going to discuss today is basically on the challenges part that industries are facing in the day-to-day life. And of course, followed by which how we'll be able to easily define a digital product information to the 3D annotated model with the help of SOLIDWORKS MBD, and how SOLIDWORKS MBD can empower the downstream processes with the concept of model-based enterprise as well. Then also, after that, let us see what are the solutions that SOLIDWORKS has to offer for the model-based enterprise, and finally, the advantages and benefits. So what is model-based enterprise? See, basically, as we all know in the current scenario, so the many companies across the globe are still under the traditional approach, right? See, basically, in the product development cycle or in the product life cycle, the first thing that we are going to do is the design activity. And of course, this design is going to serve as the base purpose for all the downstream processes that is across the product life cycle, right? So herein, once you have prepared your designs, so you're going to prepare a 2D drawing. So in what ways this 2D drawing is going to be helpful for the industries across different processes? It might be for manufacturing, it might be for fabrication. So this 2D document is going to give you an information on how exactly you're going to replicate your design into a real product. And of course, once you have done it, once your drawing has been evaluated by the manufacturer and the manufacturing has been done, then again you're going to take it into your inspection part, where you have the product control to check whether the manufactured part is in line with the design what your design guys have given. And of course, apart from this one, you can have other processes, like say for example, if you want to automate it into a CNC program or something like that. There you might have seen a lot of NC programs wherein they write the code for the model what you have designed based on the coordinate dimensions or whatever you call. And of course, you do have something like, say, for example, communication processes that has to be followed. Beyond all these things, say, for example, you need to have a track of all the revisions and worsening that you're doing for your models. That is the primary cause of using these drawings here. This is the traditional approach what each and every companies across the globe is going to right away. But what is the purpose of having MBD? What is MBE? See, model-based enterprise is a general term that is used in manufacturing. So to describe a strategy where an annotated 3-dimensional model of a product serves as an authoritative information for downstream processes. It might be for manufacturing activities like CAM, or it might be for inspection, or it might be for your simulation, like say for example your product validation. Of course, it is for any communications, and there are a lot of things that are coming across the product life cycles, right? So if you take up a product life cycle, there are a lot of processes that are happening. So how do we manage all this data? How do you have a track of the design, what you're doing? So is there any design control? So how exactly you're going to comply with the standards? So all these things are going to be one of the key aspects for a manufacturing communication, and of course it might be for other downstream processes as well. So here, what I would like to say for the model-based enterprise is that, so here in this particular concept, a single model that has been designed by the design department can be used as an annotated 3D authoritative model which can serve the purpose downstream for the downstream processes in the different activities in your product life cycle. So what is the importance of digital product information in model-based enterprise? So what is digital product information? See, basically if you take up your 3D model, what you're designing, so the basic process in the sense, like say if you take up a product design process, you're going to prepare a 3D model. Then once it has been done, you're going to do some kind of a drawings as well. Of course, as I was able to tell you from the previous slide, that is digital product information. What exactly is digital product information? See, whatever you're going to put it onto your 3D model, like say for example, is rather than creating a 2D drawing or something like that, or a drafting or engineering detailing, whatever you call, you can right away put all this information in the form of a 2D detail, I mean in your 3D model itself. So these 3D model with all the product manufacturing informations can be digitalized and can be taken forward for different processes. Let's say for example, you can reduce a lot of time here. So how you can reduce the time? Let us consider an example of a design department. Say for example, in your design departments, if there are a couple of people, one guy is working on the modeling part and one guy is working for a detailing. So rather than you invest money on a couple of people to complete the tasks on time, here in what we can do is that we can right away, the modeling guy, that is a designer who prepares the 3D model, can right away embed all the product manufacturing informations into the model, making the process more efficient and versatile. Which means the time which you are going to invest for preparing the 2D manufacturing detailing is going to be completely eradicated. And of course, the 3D PMI is one thing, and of course, the geometric dimensions and tolerances, what we call, which is going to be one of the key for manufacturing for high precision and tolerancing. So when you try to look into the different standards and you try to embed all this GD&T information into your 2D drawing, it takes again a lot of time and say information that is to be gathered. But here with the 3D annotated model, we can all generate all these things in an automated way, wherein we can reduce all this time. So what exactly we can do once this model is ready? So what are the different activities that we can take? So let's say for example, there are downstream processes as I said you, let's say manufacturing for NC code generation. If you have a 3D model, you can right away prepare a CNC program. If you want to create a process planning, right away you can do with the help of a configurations. If you want to create digital work instructions, even that can be done wherein you will be able to create some assembly work instructions and you will be able to create some kind of a communication documents as well. And of course, finally, if you take up the product inspection, once everything has been done, so it is very much important that you need to have a product control to comply with the different standards and also the criteria set by the specifications of the design department. And obviously, to make the process more effective, and in turn, you're going to have three benefits here. One is basically to reduce the cost. And of course, you're going to save a lot of time and your quality is going to be excellent. This is how you can see how digital product information can save you time, reduce cost, and you will be able to get a product quality in an excellent way. Quickly going further, let me give you more insights about this as we go into this presentation deeper. Okay, now we understood what is model-based enterprise and what is digital product information. So what are the fundamentals of a transformation to a model-based enterprise? So it is very much important that there are a lot of technologies that is coming in every day. But it is not that we need to adapt for each and everything straight away. We need a lot of things that we need to understand, the pros and cons that is going to affect the business of our company, how it is going to affect the bottom line of our organization. Each and everything has to be carefully read up. Only then we'll be able to get an information on how exactly when we try to implement a concept in our company, so we'll be able to get in the success. If we take up the transformation or for the if you take up the fundamentals for the transformation of model-based enterprise, here in say for example, the first two things that you need to understand is that we need to enforce certain standards that are required as far as the industries are concerned. So here you can see I've written a point saying that they don't mandate the elimination of drawings. So many people might think, so as far as the model-based digital product information is concerned, so everyone would think that there is no drawings here, and it is going to be very tedious for the people on the floor to understand, and there's going to be a communication gap. No, never. So that is not the scene here. So you will be able to get a clear-cut information on how exactly you're going to get your products faster to market. Like say for example, if you see the point, don't mandate the elimination of drawings. Herein, you're going to save your time and cost, but you're not going to take off anything that you're going to be doing it with your traditional approach. You're going to save papers and you're not going to invest any amount of time creating all the engineering detailing. Everything has been done on your 3D model, making sure that you have all this information. Like what exactly is enforcing the CAD standards? If you take up GD&Ts, there are a lot of codes that have been followed, like it might be with respect to the American Society of Mechanical Engineers, like say ASME code Y14.5, the thing that we are going to follow for the GD&T standards here. So when you take up a drawing, according to your drawing sheets, there are a lot of standards that you're following for tolerances, speeds, and it might be with respect to the GD&T as well. Herein, for the 3D model as well, if you're going to transform it to a 3D environment, you need to make the product more digitalized. So you're going to even follow the CAD standards that are embedded. That is going to give you more information. And of course, communication is going to give you communication is going to be one of the key things. Like say, for example, whatever you're doing it has to be communicated in a proper way. Only then you're going to get your product reliably, right? So and also you need to have a quality to be excellent here to avoid all the non-conformance that you're getting during your product development cycle. It is very much important that you need to have an appropriate communication process across the different departments of your enterprise, making sure that whatever you're preparing from a single source has to serve for all this information across the downstream processes. And of course, if you take up a prepare for a culture, you can see, for example, it is not that there are a lot of companies in this globe wherein which there might be a couple of employees who are well versed with the concept of MBE, who is trying to insisting on their top management to implement the concept of MBE. But it doesn't mean that there are certain companies wherein the company employees doesn't have any knowledge about this one. It doesn't mean that they don't need to transform into this modern processes. It's all about, say, the pilot approach and the training that we are going to take it to make sure that they are going to get the complete information about what exactly they are going to do it and how it is going to help their organization to get the process more faster and effective. So these are the 5 fundamental things that we need to understand. We need to stay ahead of the competition with all the necessary standards that we need to follow. And again, say, there is no way that we are going to eliminate the drawings here. Everything is embedded in the 3D drawings. So we need to have a visible executive support and governance, wherein which there must be some awareness that has to be created across the enterprise, making sure that we have an appropriate thing to go ahead. And also the communication is going to be one of the key things. And finally, preparing for a cultural change is nothing but, like say, for example, even if you don't have anyone in your organizations, if with the appropriate pilot training that you're going to get, of course, you're going to you can implement your model-based enterprise in your organizations more effectively. Like here, I would like to tell you one thing. The model-based enterprise is going to run your entire organization more effectively, and you're going to get a lot of, say, time savings, and also with respect to your cost as well. And of course, your product qualities which you're going to deliver to your customers are going to be excellent. So here, this is one of the important things that we need to see. What are the industry challenges? See, with the traditional approach, let us take an example of the basic approach what we follow now. So I'm a designer now. So I have designed a model and I have prepared a 3D drafting. So in case, say, for example, if there is any changes in the revisions, or say, for example, if there is an engineering changes or engineering notes has been raised from the production floor. So there will be a lot of changes that has to be done again during the transformation process from the production to your design. And again, you have to create a new version or a revision. And again, it has to be sent, and a lot of documentation has to be done. So if you take up a manual process, how exactly you're going to do this? How exactly you're going to manage all this data? In order to do all these things, you're not going to meet your requirements on time. They are going to face surely there is a delay in the time to market for a product at the final finish stage. And of course, say, for example, recreation of 2D drawings for the 3D models, and it's going to be a cumbersome exchange process. That is what I told you. So even though you prepare a 2D drawings or a 2D engineering detailing with high precision and tolerance with all the design intent, so again, it's going to be very difficult for you to, say, for example, communicate between different departments, or it might be with respect to the stakeholders as well. Managing multiple versions and revisions. This is one of the key things that you need to take into considerations. So the more amount of revisions or versions that you're going to make onto your products, it is very much tedious for you to store each and every version there. wherein the file replication takes, and say for example you need to invest a lot of amount onto your IT infrastructures, and of course it's going to get you a lot of mess when you want to go back to the required version or version within an instant of time. Communication is again one thing. So as you all definitely know, there's a lot of technical communication that is happening here, like say for example as assembly instructions, or it might be with respect to say for example your creation of your product manuals, or it might be your dismantle process of your assemblies. There are a lot of things that you need to take into consideration, right? So how exactly you're going to do this effective communication? So rather than you make all this onto a paper with a lot of texts or something like that, so again it is going to serve you a lot of problems. So how exactly you can overcome all these issues? So next would be, say for example, the misinterpretation of design intent. See, if you take up a generation of NC code or a CNC program, so you might have seen a lot of CNC programmers, right? So with the help of the 2D drawings, what you're giving, they are going to just frame the codes, the X, Y, Z coordinates based on the dimensions what you have given. There might be a chances of misinterpreting of design intent. Let's say design control is very much important in an organization, wherein which whatever the information that has been shared by the design department has to be completely taken throughout the product's end stage. So any kind of a misinterpretation of the design intent at any stages, like say for example during the programming or the manufacturing part, it's going to take a lot of problems that you're going to face, and again you'll not be able to have a track on what exactly you're trying to do. So in order to overcome all these difficulties, it's very much important that you need to ensure that you have a sophisticated information that is to be passed from the design to different departments of an organization. And finally, quality and reliability is one thing each and every organization across this globe is striving for, and wherein you can see what are the quality and the reliability you're going to provide on your product. It's going to give you a shake onto the bottom line of your organization. So now let us see what are the solutions part here. So as I was able to tell you, digital product manufacturing information or digital product information. So what is digital product information? So what is the solutions that we have from SOLIDWORKS for digital product information? Here in SOLIDWORKS MBD, that is the model-based definition, is a tool that is going to give us all this information about how we are going to define our product with all these digital PMIs, GD&Ts, and also all the manufacturing information is more precise and faster now. So SOLIDWORKS model-based definition is an add-in for the SOLIDWORKS CAD software, wherein which helps companies to define 3D PMI and organize it, and say for example they'll be able to publish it in the form of a different industry standards. So it is basically not only for defining these things. Again, say for example it can communicate different aspects. It might be not only with respect to the PMI, it also complies with different standards, the regulations, and also say for example with respect to the specifications what you have defined, and also company policies. All this information can be right away embedded, and also with SOLIDWORKS MBD it can generate GD&T information as per the standards ASME by 14.5, and also say for example you will be able to include all these bills of materials, manufacturing process planning, and also say for example the engineering configurations, and also moreover you can maintain the design intent even without having any kind of a glitch that you're going to face during the later stages of the product life cycle. So this is one instance wherein say for example where I'm going to show you how exactly we'll be able to create a 3D PMI. So with the automatic dimensioning scheme what we have here, so we can select the parts datums wherein which considering how it has been assembled, and also constraining its degrees of freedoms to ensure that we try to grab up the information that is required from a model but just by selecting the features with a single click. So as you can see here, when selecting the datums, and if you just click OK, all this information with the help of a GD&T is generated. So you can capture this in the form of a 3D views, wherein which it can give you a high level of engineering detailing with all the cross-sectional details on all this information as well. Once you have done it, you can publish it in the form of a 3D PDF, which gives you an information on how exactly the manufacturing notes have been added, what are the custom properties that we have taken into considerations, what are the different views that we've added. If you come to the custom properties, and again you'll be able to even make a traceability as well, wherein you can check who has been designed it, who has verified it, what is the part number, what is the project number. All this information can be easily brought in, and of course say for example it is not only limited to that one. You will be able to even attach a STP242, which is an industry standard based, which can be helpful for you to, say for example, communicate with the further process as well. So it can also give you a visual cue with the full screen mode as well. So this is how you'll be easily able to generate the things. The one more way is, say for example, if you have an e-drawings viewer that is available with SolidWorks here, you'll be able to easily open the 3D annotated model that you have here. So as you can see here, I'm just opening this model here. You'll get all this information, 3D product manufacturing information on your screen easily. So with this one, what you can do is that we'll be able to switch to different styles. And not only with this one, say for example, if you want to make some kind of a design review or something like that, again it can be digitalized, wherein you can see I'm adding a comment saying design change required. So here, and once you have done it, automatically you can place the arrow mark where exactly you want to place it here. And also once you have done it, whatever the 3D views that you have generated in your model based definition can be replicated into your e-drawings, making sure that you can operate everything in your tabs or computers as well, rather than using papers. And of course, say for example, if you want to add some kind of timestamps, like it might be for design reviews or approvals, even that can be quickly done. At any point of instant, if you want to make some measurements, it can be done easily. So that is all about like say for example, how SolidWorks MBD can help us to define 3D product manufacturing information onto a model, and how exactly we'll be able to communicate it. It might be with respect to e-drawings, or it might be with respect to 3D PDF, or it might be with respect to STP242. All these are industry standards, industry specific standards that we have defined. So SolidWorks has to offer all these provisions wherein you can easily export it with the help of all the direct exporting options that you have within the interface. Now here, and let us see how SolidWorks MBD is going to power a model-based enterprise. So if you take up this particular chart here, you can see there are 5 different divisions. The first thing is about the model-based enterprise, which you can see on the top, followed by which what model-based enterprise is about. The first thing here is model-based definition, MBD. MBD is going to give you the information regarding your product, like it might be your manufacturing informations, GD&Ts, or it might be a 3D annotations, or general profile tolerance, or it might be concentricity. All these GD&T symbols are there. So once you have defined all these things, the next process is about communication. Whom you're going to communicate with. You're going to send it for different departments. It might be for design reviews, or it might be, for example, the semantic STP242, as I showed you. It's going to be helpful for you in the technical documentation process as well. So e-drawings can give you a visual cue wherein which your manufacturing people at the floor can easily understand with all the 3D models with the PMIs much more in a better way. So that is how the communication process or the gap between the design and the other departments are being bridged here. So wherein with help of the suitable formats or sharing formats, you'll be able to get all the necessary information. Once you have done it, the next thing would be about the manufacturing perspective. Like say for example, machining. So you want to create a rules-based machining. So how you're going to do it? How you're going to grab all the information from SolidWorks? So SolidWorks MBD has information that can be gathered from SolidWorks MBD, where right away you'll be able to capture all the design intent, and you can right away generate your CNC programs much more easier. And also when it comes to the tolerances and also the limits and fits that you have, so all this information is need not to be automatically like say for example manually entered into your models for generating all these codes. So it can be right away extracted from the model that you have defined with the 3D PMI, so all the generated tolerances and GD&Ts, wherein making the process more effective. The next one, once your model has been manufactured, next you're going to see how it's going to be inspected, right? So it's not that you all know that the modern process of inspection is something like you take a drawing and you just balloon it and you're going to export a report based on that one. So how do you automate this process? So how do you avoid these drawings? How you're going to prepare the ballooning for your 3D models, and how you're going to get out all these inspection reports from the 3D models. So we're going to see all the solutions right away when you go further in this presentation. And finally, if you want to manage all this data, it's very much important that you need to take into considerations. Like say for example, you need to have the control over the versions and revisions that you have in your engineering design to make sure that you're right on track for your product, even without any glitch that you face across any process in the product life cycle. So these are the solutions that we have from SolidWorks for model-based enterprise here. So what is it? What exactly it is? So first let us see SolidWorks Simulation. So I did not tell you anything about SolidWorks Simulation in the previous slides, but still, if you take up the concept of model-based enterprise, or say for example, if you're trying to implement model-based enterprise in your organization, it is very much important that even before you carry out all the rest of the operations in the product life cycle, it's very much important that you need to validate your product. The SolidWorks simulation can right away be associated as an add-in, followed by which once you have validated, you can go to the manufacturing with SolidWorks CAM, and once you have manufactured, you can go with SolidWorks Inspection for inspection processes like say QA and QC process and the product control area. And once you have done it, you will be able to even create some kind of a technical documentations for say for example, you will be able to create assembly instructions, or say for example, there are few organizations across the globe wherein they are going to share the product manufacturing information in the form of a .smc file, like wherein which you will be able to gather information in your technical communication tool as well, which can help you for both manufacturing and also for your assembly part as well. And finally, e-drawings and STP files can easily be associated with SolidWorks, wherein it can communicate the things much more in a clarity way. Finally, SolidWorks PDM is a tool wherein which it is going to gather all this information and keep in a single area, wherein it can have information on all the versions and revisioning that we are going to place in for a product at any stages across any processes in the product life cycle. So what is SolidWorks Simulation? See, SolidWorks Simulation is a finite element analysis tool that functions as an add-in in your current SolidWorks CAD software. So as you'll definitely know, there are a lot of companies that are into FE analysis, right? So once you have done your model, you're going to export it to a different analysis interface to perform all this necessary FE analysis. It might be with respect to different tests. It might be your static test, or it might be your linear, static, or dynamic. It might be with respect to your topology optimizations, or it might be your design optimizations, whatever you call. See, basically, it's going to take a lot of time for you to export. And again, say what happens if there is any design changes? It's going to take a lot of time, right? So how are you going to tackle all these things? How are you going to stay ahead of competition? How are you going to reduce the time to market? So all this information is very much important for a designer. How exactly we are going to get a design integrated simulation? So let's see how exactly we will be able to get all this information. Apart from this one, so as far as SolidWorks simulation is concerned, we do have solutions for virtual validations in 3 different domains. If you take up structural analysis, we have SolidWorks simulation. And if you go to your flow and heat transfer problems, you'll be able to find SolidWorks flow simulation. And of course, for the third one, that is the plastic infusion shaping, SolidWorks plastics can guide you through all the potential issues that you face even before you go take it for your manufacturing. Let me take you through a segment where there is a small example of exactly we can perform a topology optimizations or design optimizations to ensure that how SolidWorks can be a great tool for you to automatically optimize your shapes based on the strength and weight criteria that you have here, and get the necessary stresses and strength factors induced in your model during its operation. So this is one example here. This is the same example which I showed you earlier. So here you can see here the link part which I showed earlier. So here in SolidWorks simulation is an add-in here. So I'm going to perform a topology study here. So let us see how exactly I'll be able to optimize it without any manual intervention. So here we'll be able to define all the restraints and constraints that are required for analysis here. So at any point of instant, if you're going to change the model in your design interface, automatically it will be updated here within no time. And again, if you take up this different types of options for topology optimization, here and say for example, if you want to maximize your strength of this arm, even that can be done. And of course, say for example, if you want to preserve some regions into your model, making sure that what kind of a result you are expecting here as well. So the tab which you're seeing down is the design optimization tab, wherein you will be able to get the load case study, how exactly what are the different types of loads, and finally you can see this is the optimized shape that we have here. And this can be shared in the form of a new configurations in your SolidWorks CAD interface, making sure that there is no requirement of a new model to be created. And of course, finally, once you have done, you can see here with all the color coded depiction, you'll be able to find the stresses and different strength factors results as well. So next, moving further, is about SolidWorks CAM. This is the manufacturing solutions that we have here. So even though we know that we have a 3D model, we'll be able to generate the CAM program. But the concept is not about generating the CNC program here. How you're going to maintain the tolerance and precision here. So with SolidWorks CAM, we have a concept called tolerance-based machining. So tolerance-based machining is basically something like it's going to grab all this 3D product manufacturing information and tolerances from your 3D model right away. It tries to extract all the machinable features that is available onto your model, and finally from this information it automatically generates the programs. So let us quickly take a look at how exactly SolidWorks CAM can be a great tool. And also, apart from this one, I would like to give insights about SolidWorks CAM is a 2.5 axis milling tool and also a 2 axis turning. So where you will be able to perform all the manufacturing activities like generating CNC programs and creating process plan sheets, and of course making sure that you have an integrated interface for CAD and CAM as well. So this is one segment wherein say if this is an example wherein I'm going to pick the particular link part here. So I have defined all this 3D product manufacturing information here. So SolidWorks CAM being an integrated interface, you can see we have a option called run tolerance-based machining, wherein with a single click here, automatically SolidWorks will be able to extract all the machinable features. So you can see all these necessary features have been extracted onto the CAM feature tree. So at any point of instant, you can see I'm going back to the CAD interface. I'm going to change the type of fits that is required, and it is not only with respect to that one. I'll be able to even change the other dimensions with different types of tolerances as well. You can see how easily it has been reflected here. And again, coming back here with the direct integration what we have for CAD and CAM, SolidWorks will be automatically able to extract all this information, and easily it will be able to grab the tools that are required for this toolpath simulation as well, wherein you can see all the toolpath simulation can be easily performed to ensure that you get the product right without any glitch in your product as well. So next one is about the SolidWorks Inspection. So as you all definitely know that, for example, once your manufacturing is done, how exactly you're going to inspect your product. So if you take up an inspection process, so it is going to serve you in two purposes. Like say for example, one is the product control and one more is the process control. SolidWorks Inspection is a product control tool wherein which it helps us to generate balloon drawings, and of course the first article inspection reports as well. So it is not only limited for only parts here. SolidWorks can acts as a powerful tool for both SolidWorks parts and assemblies, wherein once you try to define your 3D product manufacturing information in MBD, the same can be again integrated on the same interface for creating ballooning, and of course you'll be able to generate all this necessary information as well. And SolidWorks Inspection being a standalone application, it is not mandatory that you need to have SolidWorks installed. So you'll be able to work on SolidWorks Inspection even without SolidWorks as well. So wherein you'll be able to import different types of CAD parts, like it might be from PTC and Creo parametric files, or it might be a CATIA part files or CATIA drawing or your Creo files, 3D XML. So all these files are being accessible into this SolidWorks environment, SolidWorks Inspection environment standalone application as well. Let me quickly take you through a segment wherein which let's see how exactly you'll be able to do the ballooning and report generation with a 3D model. So again, considering the same example here, so considering the link part, let me see, say for example, if you open this particular part here, the SolidWorks Inspection is again integrated onto the same interface. You can see here, this is a CAD interface. So we have different views here. So at any point of instant, if you want to create ballooning here, so right away you can go start with a new inspection project here. So herein we will be able to customize it according to different industry standards, and different information can be added like different types of vendors, operations, manufacturing process. All this information can be easily gathered. As you can see, the balloons are created within an instant of a minute. So herein, once it has been done, at any point of instant, if you change any dimensions in your CAD, automatically it will be reflected into your inspection as well. And of course, once you have done it, you'll be able to easily generate your first article inspection as report as well. So next one is about SolidWorks Composer. So SolidWorks Composer is a technical documentation tool. See, if you take up a model-based enterprise, so what exactly happens in the sense, few companies doesn't want to share their step files or 2D drawings for their tier 1 suppliers or vendors. So at that point of instant, the people who have tried to implement all have already implemented the model-based enterprise. What they try to do is that they try to share the data in the form of a graphical content. So which means you have a lot of security there, wherein you will not be able to do anything, like your other people cannot misinterpret anything on the design intent. So wherein all this information and the views that you have captured in your model-based definition can be right away transferred into your SolidWorks Composer in the manufacturing perspective again. And also it is not only limited for that one. Again, if you take up SolidWorks Composer, it is a beautiful tool wherein it helps us to create a really interesting and interactive technical documentations like product manuals, service instructions, or it might be your assembly instructions, helping the people on the floor to understand more on the design part, so which makes the process more effective and which reduces a lot of time. So to be more precise and clear here, so the thing what I would like to tell you is that easily will be able to gather all this information from SolidWorks MBD into SolidWorks Composer within just a click, and you can see how easily you will be able to interpret all these things. So let me quickly take you through a segment where you can understand how we have an interassociativity between SolidWorks Composer and SolidWorks MBD. So going back to the same example again, so if you take up this particular part here, you can see I've defined all this 3D modeling information here. So right away you can go to the 3D views tab where you can see all these 3D views are being generated now. So say for example, at any point of instant, if you want to change it into form of a graphical content to share it to your tier 1 suppliers or vendors, so SolidWorks has direct integration wherein with add-in options you will be able to export it in the form of a .smg as well. So once you try to save this in the form of a .smg, this is a SolidWorks Composer interface wherein you can see you can open that particular file. If you open this particular file, so automatically what will happen, all this information that you have gathered into your 3D model, you can see all this product manufacturing information will be right away available here. So you can align it over the different places, and again say for example, if you go to the types of views, you can see the front views, the side views, the sectional views, all this information can be right away gathered here. And also if you want to have more information on the 3D PMI, and again you will be able to have the traceability for all that as well. So if you want to create some kind of an assembly instructions, you can see for the same model I have taken, you'll be able to create exploded views with bills of materials, and say for example, you can gather all the information for the complete model as well. As you over onto the single parts onto your BOM, you'll be able to get a clarity on the complete information. So it is not only limited for that one. If you go to different rendering styles, you can see all this information on the model can be viewed in different perspectives, like it might be in the form of a silhouette, wherein you can get only the 2D outline. And of course, if you go to your other kind of things, technical illustrations, you will be able to get. So you will be able to generate a scale vector graphic image wherein it can be directly clubbed into your websites, which can be easily opened with the help of your browsers, wherein you can see it's a graphical content that has been prepared and can be easily exported into your browsers easily. And also high quality resolution images can also be easily created as well. So this is how we'll be able to implement a model-based enterprise into our organizations, wherein you can see easily you will be able to integrate the 3D model for manufacturing, inspection, technical communication, and again say with the help of e-drawings and STP files, you'll be able to export all these things to your Composer for technical documentation, and also with SolidWorks Simulation for the same CAD model with the same design intent, we'll be able to easily create our virtual validation as well. So what exactly is SolidWorks PDM? As I was able to tell you during the earlier phase of this presentation, so the concept of versioning and revisioning. So whatever I spoke till now is a complete technical data package that we have. The technical data package 3D is going to serve the complete product life cycle. So herein, what SolidWorks PDM can do is that if you take up the first thing, herein you can see the file management and security. Say for example, what are we doing it? How exactly are going to manage all this data? So how we are going to maintain the interassociativity between the different parts, like it might be with respect to your technical documentation, inspection, or it might be your 3D model, or it might be your simulations. How exactly are you going to have the value of your revision or something like that? So how we are going to understand it easily, and how we are going to securely place it in a vault wherein say you'll be able to easily access it, and also say you can deny permissions for people who doesn't want to work on this particular files for any misinterpretations. Next one, say for example, you will be able to easily create workflows and approvals. So rather than you do all the manual processes for your approvals and workflows, you will be able to, say for example, manage all this information electronically, wherein you can get electronic approvals, and also say the workflows can be say created for different departments across your companies, and it can be connected across different units as well. Next one is about the communication process. This is one of the most important things. Say for example, here you will be able to easily communicate across the global network, wherein you will be able to easily collaborate between the different departments or different units of your organizations, and you will be easily able to organize and manage design data. And of course, if there is any replication happening, so you'll be able to easily have a track on this data, like say for example the history of the file, making sure that what exactly are the changes that have been done and how exactly this can be overcome if there are anything that has to be replicated back to that particular stage as well. So finally, it's all about the file revisioning, as I told you, and finally work traceability. This is one of the most important things. Say for example, in your organization, say if you have 10 designers, and say for example if you want to have a track on the projects or on the design activity, or say for example it might be with respect to any departments, so easily you'll be able to even make the traceability for the works what they have done. And in case, say for example, if there are any misinterpretation happening, you'll be able to get all this information within just a click as well. So finally, coming into those advantages and benefits. So what exactly you understand from this particular thing. So as we were able to see, so with all this implementation with a single 3D annotated product manufacturing information model, we'll be able to create so many things, so which ultimately reduce the time to market. You can save a lot of money in the production, and of course, say for example, it might be with respect to the investments in the tooling design, or say for example for fabrication activities as well. And if you take up the technology, your technical communications, so by implementing this concept of model-based enterprise, and again, say for example, you can save a lot of assembly hours, you'll be able to avoid a lot of reworks, and say you can have a streamlined process, making sure that you have a better collaboration in the engineering changes that you make in between the different departments of an organization. And with the design integrated simulation that we can have here, so at any point of instant, if you are making changes for your design, easily you'll be able to make sure that you replicate into your virtual simulation interface, making sure that you have your designs perfect even before manufacturing. And finally, managing engineering data is more feasible, where SOLIDWORKS PDM can collaborate and integrate all these interfaces on a single user interface, where you'll be able to track all this work that you have been doing, and what are the different revisions and versions that you are going to prepare, and how exactly the work traceability can be found in your organization. So what I would like to conclude here, so what exactly we are going to say here. See, it's not about what the changes that we are going to implement in our organization, right? So ultimately the thing, even if you are not able to understand or aware of the concept of model-based enterprise in your organization, but still if your organization wants to implement all these technologies in your organization, how exactly the concept of these PLM tools and also the CAD tools are going to play a major role in defining the proper set for your product life cycle. So a right pilot program, training and reinforcement in place can give you a lot of information, making and bringing a lot of confidence for the people across your organization to recognize the potential that they have in implementing model-based enterprise. So this is about the general slide wherein I'll be giving you an insights about the SOLIDWORKS design to manufacturing ecosystems. So if we take up the SOLIDWORKS design to manufacturing ecosystems, right away from design, we have SOLIDWORKS CAD here. If you talk with manufacturing, we have SOLIDWORKS CAM. If you take up the electrical perspective, we have PCB and also SOLIDWORKS electrical as well. If you go to the validation tools, we have SOLIDWORKS SOLIDWORKS simulation, flow simulation, as well as plastics as well. And also in the product quality control domain, we have SOLIDWORKS Inspection, which can serve you for preparing balloon drawings, and also you'll be able to easily create first article inspection as well. And of course, SOLIDWORKS MBD, which was a major topic for today, it can easily create 3D PMI with all these industry specific standards, wherein it can integrate all these apps or applications on a single user interface, And finally, SolidWorks PDM and Manage are the data management and the project management tools that we have in SolidWorks. And also, Xsolid one part is the advanced part search part we have. Xsolid one part is the advanced part search tool that we have here, wherein we'll be able to get all the information with respect to the standard components that we have across this globe. And say, for example, SolidWorks Composer can help you create some kind of a technical documentation. eDrawings is going to collaborate all this information from SolidWorks MBD, from the 3D model, and say, for example, all the manufacturing information as well. SolidWorks Visualize is a tool that is going to help you in the product styling process, wherein you're going to get your products faster to market rather than you face all this delay due to the traditional photographic approaches that you follow to create some immersive technical content, interactive content. Above all these things, we are emerging into our new platform, that is the 3D experience platform, wherein we'll be able to find couple of acts, that is for industrial design and for conceptual design. So here for industrial design we have Xsheep. So for example, for conceptual design we have X design, wherein which gives you more fluidity to create your product design process more faster, and again which can be right away integrated with SolidWorks on the same single user interface, making sure that you are working collaboratively and ensuring that there are no data loss, and you, say for example, you're going to work in a collaborative manner more faster and effective. So these are some of the prestigious customers of Conceptia or using different solutions of SolidWorks like Shea. So we have Eureka Forbes, we have Cosmo Instruments, Exonic Precisions. So where in ITC Infotech, they are using MBD inspection, and there are many companies apart from this are also using different solutions of SolidWorks. So the agenda of this today's webinar would be, say, integrating all these applications on a single user interface is going to drive the process more faster, and it's going to help you drive the productivity again to the next level. Okay people, I see there are no more queries coming in, so I would like to thank you all for joining this webinar. Thank you for your time. So stay safe and stay connected. So stay tuned for our next set of webinars, wherein we can give you more information on the SolidWorks set of solutions. Thank you all for joining. Once again, thank you.